Good evening. It is day, I believe, 108 of coding every day. Um, um, haven't done much today, which is kind of, again, hey, I'm on break. Okay, let a man live. I do need to start getting stuff moving because I'm pretty sure, like I said, I have like a linear algebra and I think also a algorithms exam, like at least one of them the week I come back from break and another one the week after. So, but I think also the week after I have the computer architecture demo. You know what's crazy is it's literally like I have after this week I'll have like 6 weeks until semester's over. These semesters move so fast. I mean, like my semester doesn't start until February, so it's been a month and a half, but I only have another month and a half to go, if even. I think with final weeks it is another month and a half, but crazy. So, um, but not working on. I don't think I'll do any of that work on these videos. Um, what this is going to be is computer architecture. Also, I think I might give another crack at that code visualizer thing because I was thinking I've been seeing a lot of like on my YouTube recommendation, a lot of like startup stuff, and um you know, see, it's like I don't want to get into it for like the prospect of like a successful business and like making a lot of money or whatever because then it's like I'll repent the work. Um, and so that's why I'm like hesitant because I think the code visualizer idea is pretty good because the whole thing is like my Quibbly app. I'll never put that front facing towards like selling it because it's nothing new. It's a task scheduler and notes. I just made it so it catered to me because I wanted something really simple. That was something really simple. Um, and so it's like I would want something that like fills something that's kind of like undeniable, like fills a hole in a market that like it doesn't have to be a big market, but uh, you know, it's definitely there's definitely a problem, and it would be a solution. And so I think the code visualizer thing is like something along those lines because I feel like with generative models, you can get information like this now, but it's all text information, um, and that's good for some people, for others, like I mean, especially like for me, I guess, like when I'm just looking at like, especially for mathematics, it can be hard to just like read text and try to see what they're getting at. But at the same time, with like the whole code visualizer thing that I was going for, it's like I don't know how good I could even get, you know, those visualizations. I mean, that's why another reason I want to get another crack at it to see like how far it could go at showing like if I want to see how you get you know I don't know the inverse of a matrix, can it actually show that well? I know that you can make it show it well with the Manum code, right? Anything mathematically is possible to represent with that code, and that's why I think it's pretty great. But um, can I can't imagine the amount of training it is going to take to get that thing good because like hypothetically I definitely could. It's just gonna be so much because hypothetically, yeah, I could like. I was trying to think because these need to be like kind of long visualizations. So I guess they don't have to be long. I don't know. It's like because if I want to train on like matrices, geometry, calculus, algorithms, like so many different fields in which I would want it to be able to represent. Um, then like the amount of data the amount of Manum code examples is going to be disgusting. Um, and so I would have to implement first. Obviously, I'm not going to do that by hand. It would have to be something where I give a prompt, right? And it gives me a response, and I click yes or no, and it sends it to like it sends that code as the file and saves it into a thing. And then I would have to be just doing that for days, you know. Um, yeah. So I don't know. Because there's nothing else, and I also don't want to like, I don't know, search for a like a problem, right? I feel like going on a search, I feel like I would just, if anything, I would just want it to come organically, like how, the code visualizer thing came, where it's like I have something that I want a solution for, and then I'm like, do I think other people would want this? And if it's yes, right, then go and like try to build it, and that can be like a project I pursue, a project that I would try to market, I guess. But yeah, I don't know. I'll have to think about it more. Literally, I was just thinking about it like an hour ago, and I was like, maybe I'll try to go with the code visualizer thing. But today, I don't think I'm going to touch that at all. I think we're just going to do computer architecture today. But I'm not sure what I want to work on today. I think either I'm going to look at the UI, um, that software that we found the other video, for UI, or and look at the assembler and get my instruction set together. Um, Also, at the same time, I don't think I have to define. Nah, I guess I do have to define the instruction. But anyways, it's more like so. I'm assuming the assembler is, from what I've seen, it's just like a switch statement, right? Where it's like given, where like so you put in your assembly code, and it's like if, and you do like a string, whatever, and it's like if, the first part of the input, which is the instruction, um is add, right? Then go into this switch statement, and then we're going to take this register, add them together, and put it. Well, that'd actually be execute, right? The assembler isn't doing that. The assembler is saying, if it's add, make the opcode this. Let's look at what the registers were specified. Okay, make this part of the encoding instruction, register. If it's register 1, then I actually don't know. I think it's just 4 bits. So 001 or whatever. Or 0x01 or whatever we're going with. And then whatever the destination one. And I just split it up into the encoding, right? And then all I have to do is take that encoding and just send it to memory, and have that instruction just sit in memory. And then fetch will go and take that. And then decode stage will take each part of that and say, okay, we're going to add this register and this register. So I'm going to take this register. So I'm going to take that, and then then do a request to the registers, right? To get the values. And then the whole thing is going to be ready for execute. And then you're going to throw that to the execute stage, right? And all execute's going to do is just, I mean, in that situation, it's going to add. And so I'm working on the assembler fetch and decode. And my partner's working on the execute, write back, and memory access. So yeah. Um, Okay, so I'll be right back, and then we will, I guess, just start looking at the assembler. Um, and if I get bored of that, then we'll look at UI. So, right back. Sorry about that. I am back. Uh, I want to put on music. Okay, let's start with the assembler. Um, about it. Sad about it. Okay. What branch am I in? Processing, yeah. Okay. CD into assembler. Actually, you know what? I'll just do this. And then I want a new instance of this. Okay. So, I assume just what an assembler is it's going to take some type of input, right? So this is going to be not a def. So this isn't going to return anything. This is at the end of this. It's going to just write. It's going to write to memory. Right? Because if I have the instruction of like add R1, R2, sub R2, R5, branch, or jump to something like this, right? What I want is this is going to be a file, right? And so when we pass through the file and hit run on the simulator, it's going to take this and it's going to go through this line, right? And it's going to convert that into this assembler is going to convert that into our instruction encoding. So it'll be like, I don't remember what add is, but it should be something like opcode of this, register of this, register of. Actually, this is 16-bit. So is this two 8-bit registers? It's just that. But like, right, I want to convert it into this, and then this will get turned. That'll get saved to DRAM. So. Right. Let me look at the actual. Oh, 3 register. That makes sense. Okay, so it's actually 0, 0. Okay, 0, 0, 0, and then it would be. These are all 4-bit, so it'd be like. So if we're adding register 1, so this would be adding destination. So destination could be, I mean, yeah, it could be register 1 and then register 2, register 3. Right. And then Whatever. For now, I'll just do. Oh wait, yeah. With 4 bits, I can represent up to. What is it? 16 values, right? Well, 0 through 15. Is it 0 through 15 or 0 through 16? I can have 1, 2, 3. Well, okay, I can have 8 plus 4 plus 2 plus 1. Okay, 15. So 0 through 15 is what we can represent with 4 bits. So this wouldn't be hexadecimal. This would just be this, and then this would be this. But this is not correct. That's opcode, and then register 1 would be that. Okay. So destination. So we have this, and then this will save to DRAM at the program counter. Whatever address that we're looking at. I'm pretty sure. Actually, I don't think it would be at the program counter. I think it would just be... How would you save it to DRAM? Like, keep track of where we want to put it. I assume we want to split up memory as well in DRAM and just have, like, specific instructions stuff. I'm going to use the bathroom real quick. 1 second. Okay. I came up with the... I did a little riffing with ChatGPT, but it actually didn't help me at all. I think what I'm just going to do... I have to figure out how we're going to handle the program counter. Like, is that a global thing? I don't know. Anyways. What I think I might do... Actually, no. I can just do it... So what I think I might do is I'm going to have memory divided up. Where address 0 through... I don't know. 500 is just for instructions. And we're going to load from that until whatever. And every single time we run a new program, it just clears out that section, sets it all to 0. And then goes through and we'll have a pointer that's at 0 and keeps incrementing a new 2 byte chunk and move to the next one. So, yeah, I think that's what we're going to do. So, I mean, first things first is the function that we'll be calling, right? So, I think what we'll do is we'll call this function. We'll call this function with the parameter of DRAM and the loaded file. Okay. So how can I do file processing in? Uh, so let's include these. And so this is going to be a void. Load instructions. And this is going to take in. Is file a thing? Can take in a file in DRAM. And we have, well, actually, this would just be file. Actually, no, I don't even need that. FBTR. Not FBTR. Is this an instance of a file pointer variable to store the value returned by fopen? Okay, so I want, so what is file? So this is a pointer, just variable. And then we set the pointer variable equal to the opening of said file. Hmm. Has did. So it is that. I was right on that. But then you'd also just make a file open, send the file, then process the file. Give me this. I think it's a string that I'm missing. So file, whatever. So actually, fuck DRAM. From simulator, what we'll do is we'll call. Let me outline this. We will from UI actually, because we're not using the simulator anymore. From UI, call to this with for each line and directly. Ooh. Oh yeah, and directly save to DRAM from. Oh, but that's like not good, eh? I don't want this to be client bound, right? I don't want this to be like. Because like what I'm thinking of it is like, so we have the UI set up, right? When I hit like load file, and we get a text file of assembly code, it should pretty much go instant, but as we upload it, right, it should go through each line. And like, okay, so take like the first line, like an example like this, right? And so it takes that line. It goes through load instructions. And so I was thinking, I have to have an instance of DRAM. So I think it's fine because I think what the UI is going to do is it's going to interact with the simulator.c that we've been using. But that file is going to transfer into just kind of like an initialization file of the simulator of all the values and everything we need. And from there, the input is going to be on a while loop. And it's going to say for each line, until there's no more lines in this file, we're going to take each line and we're going to pass it to load instruction. Okay? Load instruction is then going to return it's then going to return we need to make a new file. We need to make we need to make a header, and what it's going to do is that header is going to specify never mind. Because it would be easier if every return from this went back to the main thing that has the reference of DRAM and just saves that wherever the program counter is in the main simulator. That would be the best. But what is the return type on that? All of these are different. I guess the consistent thing is they're all 16-bit, right? I wonder if that's a thing I can do. I wonder if you can do like kind of a, yeah, like a big. Type def union. I don't like this. I mean, I could just do. Ugh. No, this isn't bad. It's just. So what's a type def union? Didn't help at all. fuck is this? Or equals? Ugh. I don't care, bro. Okay. Oh, this is two different things. Um, Writing something, mask out everything except for the lower 4 bits. Okay. Okay. Actually, it may not be. This hurts my ears. Alright. So never mind. Ah. Oh, I was gonna say we've only shifted to 8. What happens to like the overlapping? But yeah, it's sick. Okay, that's just actually sick. Okay, fuck the header for at least right now. Give me back here. Okay, so we take in the file, and then we have just a void, right? We don't care about what this is actually turning or anything. Or we do. Oh yeah, what am I saying? What am I saying? Assemble line calls to this though, right? But it should be. Oh, you know what I can do? So this is good. This is good. I do want this. Also, this is now not where I want this. So what I want is, oh, this is new. It's 16 underscore T. Um, is this RRR type? So I want to name this. And so this is taking in what? It's taking in anything? What would this need to take in? Well, it needs to take in all the values of the stuff, right? Yeah, the opcode, this, and this. I guess what you can do is you take in the line, right? So this isn't the file, this is a line. Const char line, whatever. Oh, excuse me. Right, so we're going to take in a line, and then based off this line, right, we're going to look at the opcode. Well, actually what I should do is in the header file, define each of these types. Okay. So, what imports do I need? Do I not need in? Okay, give me you. So I think what I'll just do is do a type def. What did I do for? I want it to be a struct. Right, and so I want this to be, well, for this one, it'll be an opcode of what? Char 4. And then register 1 or register D is a char 4. Register A is a char 4. And register B is a char 4. Right, and so this is going to be an RRR type. Well, right, and so I just want to do this for each type that I have. That way it's just easier for, okay, that's not what I wanted. Okay, so next one would be a RRI, which is going to take in a destination and A. Wait, why'd he change this? I swear. Can I look at the history of this? Yeah, I had an immediate of 6. I don't know why he changed this off of 6. Why wouldn't we just use the bits for a full immediate? When does he change this? It's on the last one that he did. I mean, is that just not just stupid? Whatever. I'll put it as 6 bits. Whatever. Wait. How are the bits comprised? 4-bit here. Am I stupid? What am I? Oh, it's because he has the I here. That's why it's tripping me up. Okay, it's a register. Oh, no, it's a register. Oh, wait, I don't even think I did that on purpose. Okay, so it's just register to register. Again, though, what did we have beforehand? We just didn't have a register to register. I had a register immediate, which had shift options, but I think it was just like an immediate shift. But this is taking, so I don't know why the second register wouldn't be like bigger. To be honest, I don't know why the non-destination register just wouldn't be bigger. Right? I'm just gonna make it bigger for now. Okay. And then we have, now we have the RR register immediate instruction. You know, I'm gonna lowercase these I's. RRI. So this is going to have our 4-bit opcode, 2 registers, and immediate. So this just changes to an immediate. Then we have... Is that it? Oh, nice. Okay. So those are those. Yeah, let me just open this in a... So... And so this is just going to take in... Well, oh my god. So we take in the line, right? No matter what, we're just breaking it up by like spaces, right? But based on the opcode, right? Which is an instruction at first. So let's say we do an if statement that's like if it's and, right? If the first thing that we get, the opcode, because we're always going to have the opcode, if it's and, then we know, okay, this is what I can kind of do. It's like if we know, so we take in the line, right? And we divide line up into, or just get the opcode. Get the opcode. Okay, we just get the opcode assembly. Right? Once we have the opcode, then we can go through and can say if. And for now, I can just say the opcode const I know it's all with C, I mean, all with char, but char, that's where it is. We'll just say this for now, right? And we'll say if char, or wait, what am I saying? This is just char opcode. If the opcode is equal to add, right? Then we know that now I think this is going to work in terms of You motherfucker. Hello? I'm literally pressing. Okay. But I never ban out. Wait, I did too many. That's pretty sure. You know what? Just so it looks better. And it won't affect performance, really, I don't think. And it makes it look like I planned that better than I did. Look it down on the white. Up on the brown. Look it down on the white. Okay. So.
Locations where the album was recorded include No ID's studio in Los Angeles, Logic's house in the hills, and various hotels across the country throughout the duration of the tour.
Okay. So based on any of these, let's say it's like, say we get ad, right? If we get ad, we want to say, well, actually, I'll define an RRI or an RRR in called I guess RR is it RR immediate? Okay, and so then if I go into here, it's going to be RRR dot opcode is equal to opcode. Or actually, no. Opcode is equal to... Actually, that's an... I define those as chars. I don't want those as chars, right? Yeah, these are uint. How did I define that in... memory? Beforehand, yeah. So all of these should just be... All of these should just be that, actually. Okay. Oh my god, I hate you so much. Oh yeah, sorry. That's exactly what I did. I'm gonna do that. Oh, but this becomes reg D. Yeah, okay. Alright, beautiful. So now opcode is equal to... Is this just... Do I do just this as like hex? Okay, so it is just equal to... But that's that. I want like the actual like... Oh wait, why am I in here? So the value of the opcode would just be... It's been an hour and 10 minutes, jeez. Time flies by when you're having so much fun. Computer items. Computer architecture. I guess I can just do it. Okay. I know I didn't think about that. So opcode is this. Register A is equal to... I mean, whatever it's equal to. I guess we'll say 1 for now. Actually, this would be... D is equal to that. A is equal to 2. You go to 3. That's it, right? Yeah. So now we have all this, then we can call to... Actually, I can just do that, right? I can just pass through the object of this. And this is going to take in... the address of... And so what? Do I just pass the address through here? Okay. Right, and so then it's going to go through here. We'll flesh out the logic here of what that's going to do. But then technically it should just return this. And so void is going to be... just this. Beautiful. So then in simulation, this will get back just that. A 16-bit bent. Yeah. Yeah, I should get this distinction out of my head that like the integer and binary values are so like it's the exact same thing, just how it's like being printed, literally just how it's being printed to me, right? So if I just do bit shift stuff and I like get out these values, then it should be good. So it says everything's good. Pitfalls comparing. Oh yeah, I do have to do that. I always forget that. Let's do that, and then I'll probably wrap this up because we're at a decent point. I want to go eat. Okay. Oh my god. Okay, so it's gonna be just like something like this, right? So the whole thing is in my. Yeah, I can go to just simulator. Loop.c. So this is all gonna get removed. I mean, honestly, should I just delete it all now? Here, I'll delete this. Wait, why was that? Oh, wild truths. Oh, I deleted that. Return buffer, I don't care about anymore. Input, command, stage, add value. Regex, okay. The whole queue I don't need at all anymore as well. So that's something. Oh, whatever. I'll deal with this a different day. But basically, the only thing I wanted to get my point across was if, let's say here, right, we take in the input, it gets taken in, whatever, from regex matching. Or no, because it's not our input. So we're going to input a file, right? So none of this matters anymore, really. But I'll keep it here for now. And basically what it's going to do is, so, I mean, look at the main file. The main file, we're going to upload a file, then we're going to get the file, then we're going to call to this, right? We're going to call to this with the file, and we're going to have a while loop. And while there is something on each line, we're going to pass through that line. That line is then going to get broken up into just its opcode first, right? We're only going to take the opcode because we know every single thing that's passed to it is going to at least have like that opcode, right? So we're going to look at the opcode. And so if it's add, right, then we specify, we already created each of the types that we have for instruction encodings. And we're going to go through, we're going to take the values, set these values to whatever integer value they were, go to our encoding, and then our encoding is going to set the whole binary string correctly. And then we're going to return that back to the to this, to here. And then as soon as it's finished and it comes back, we're going to send that to DRAM at whatever address we're currently at. And then we're going to increment the address by 2 bytes, and then we're going to go through the while loop again, right? And we're just going to keep going until DRAM in our instruction section is filled with the instructions. And so then we can move on. So now it's staged, right? We have all our instructions and we're ready to execute. So then we can go in the UI and press like just a run, and then that will go through our pipeline. So right now what I'm working on is, the assembler to get it all staged and prepped. And then we'll start working on the UI. And then I think once we have the UI, I'll go through and a sort of just have the UI, and then we'll go through the fetch stage. So literally just having a program counter going through fetching each thing, right? We'll just make sure that it's going through correctly and, whatever. And then once that's set up, I'll go to decode. So it'll take each instruction, decode it, put it into just take the string, take the opcode, and be like, okay, this is what we're doing. We're adding. And then we're taking the register, this and this. These are 2 register values, right? So now we know we're adding with these 2 registers. Then we pass it off to execute. Execute's going to know exactly what it's getting. And it's going to be like, okay, we're taking these 2 values based on this opcode, and we're like combining them. And then we'll go to like the memory access stage, and then write back, and then maybe it does a write back or something, or it sends it to a register or something. But yeah, okay. Well, that is all that I have for today, because I want to go have some dinner, and then go to bed. So yeah, finally got a decently, not that long, but it's been better than recent days. I think the last 2 days total like 15 minutes of recording. So, but yeah, this is pretty good progress. Hopefully tomorrow I'm going home, and I'll be there for 2 days. So both my videos will probably be from home. So yeah, we'll see. We'll see what happens. With that. I will see you tomorrow from my parents' house. And we'll probably just work on this some more. Okay. Take care. Bye.